Here's a tour of 5 military prototypes that looked like time travelers, machines that previewed capabilities the world wouldn't field for decades. Each one blended bold vision with bleeding-edge engineering, and each ran headfirst into the realities of politics, budgets, or doctrine. From stealthy wings to a reusable spaceplane, these prototypes show how far ahead some ideas really were. Number 5. BAC TSR-2 UK 1960s. The BAC TSR-2 was conceived as a low-level, terrain-hugging strike aircraft that could sprint at supersonic speeds and still deliver precision on target. It combined powerful engines with advanced navigation and attack systems, including terrain-following concepts that allowed safe, automatic flight through bad weather and rough air at very low altitude. The airframe was optimized for long, fast dashes just above the deck, where radar coverage was weakest and survivability highest for its era. Engineers pursued an integrated avionics philosophy that sounds routine today, but was borderline science fiction in the early 1960s. Crews would have had a cockpit built around sensor fusion rather than isolated dials, enabling faster, more confident decision-making under stress. Its mission profile, high speed in, pinpoint strike, high speed out, anticipated the tactics later associated with specialized strike aircraft. Even in its truncated test life, the TSR-2 demonstrated the kind of systems integration that modern jets now take for granted. The program's downfall was not technical daring so much as the collision of cost, politics, and shifting doctrine. As budgets tightened and strategic thinking evolved, decision-makers questioned whether the RAF needed such a specialized and expensive platform. Cancellation halted the transition from impressive prototypes to a mature weapon system and left crews without the capability the aircraft promised. Yet its avionics approach, emphasis on low-level penetration, and systems integration influenced later European strike designs. Veterans and historians often point to it as a symbol of what happens when ambitious engineering outruns political appetite. The airplane's museum piece status belies how modern its concept still feels when read against today's precision, all-weather strike requirements. In a different fiscal climate, TSR-2 might have redefined European air power years earlier than it ultimately evolved. Number 4. Horten Ho 229, Germany, 1940s. The Horten Ho 229 married a jet propulsion era barely out of infancy with a tailless flying wing planform that minimized drag and frontal area. By eliminating the conventional tail and blending the fuselage into the wing, the design reduced the surfaces that created radar reflections, even if the term stealth had not yet been coined. Built with wood and other materials that were readily available late in the war, the aircraft still aimed for a performance envelope that would challenge conventional fighters. Its aerodynamic purity foreshadowed the efficiencies later exploited in long-range, high-lift wings. The prototypes demonstrated the feasibility of the concept despite the chaos and resource shortages of the final wartime years. Engineers were betting on fundamental aerodynamic truths: fewer protrusions, fewer wakes, less drag, more efficiency. The fact that such a radical platform even flew at all under those constraints is part of its legend. Modern assessments and replica studies have suggested the Ho 229's shaping could have reduced radar return compared with its contemporaries. While that would not equal modern stealth, it shows the Hortens were thinking in the right direction, decades ahead of the curve. The airplane's influence is less about a direct lineage and more about validating a family of ideas later seen in stealth bombers and UAVs. It also highlighted the handling and stability challenges that come with tailless designs, challenges that later digital fly-by-wire systems would finally tame. The Ho 229's short life means we will never know its full performance potential, but its conceptual fingerprints are everywhere. In aerodynamic research, in signature management, and in the romance of the flying wing, it became a lodestar. The machine stands as an early glimpse of the stealth era before the technology to fully enable it existed. Number 3. North American XB-70 Valkyrie, USA, 1960s. The XB-70 was an audacious attempt to make a strategic bomber outrun the threat, flying at Mach 3 and stratospheric altitudes where interception was nearly impossible. Its designers exploited compression lift, drooping the wingtips to ride its own shockwaves and claw-back efficiency that high-speed flight normally burns. The structure pushed materials technology with honeycomb panels and heat-resistant alloys to survive the thermal realities of prolonged supersonic cruise. Everything about the Valkyrie reflected a singular purpose: go very fast, very high, very far, carrying a strategic payload. Its flight test program expanded the envelope for large aircraft operating near hypersonic regimes. Crews learned about high-temperature aerodynamics and control at speeds that most military jets rarely see even today. In many ways, it was a university on wings for extreme-speed bomber design. Strategic context changed faster than the airplane could mature. Surface-to-air missiles and evolving doctrine undermined the high-altitude, high-speed bombing concept the XB-70 was built around. A tragic mid-air collision during a photo mission eliminated one prototype and cast a long shadow over the program's momentum. The surviving aircraft shifted to research, where it continued to yield data that informed later high-speed projects. Lessons in materials, thermal management, and shock interaction aerodynamics echoed through supersonic transports and fast reconnaissance aircraft. Although it never became an operational bomber, it contributed to the body of knowledge that makes modern supersonic flight safer and more predictable. The Valkyrie proved that sheer speed is a harsh master, and that engineering brilliance can still be overtaken by strategic reality. Number 2. Alexeyev KM, Caspian Sea Monster, USSR, 1960s. The KM was the physical definition of think different. Neither ship nor airplane, but a ground-effect leviathan that skimmed just meters above the sea. In that thin cushion of compressed air under its wings, it could haul heavy payloads at speeds far beyond conventional maritime craft. The design promised strategic mobility for coastal militaries, moving troops or equipment rapidly without runways and with reduced detection from horizon-limited radars. Engineers tackled unique control problems because flying so low over the water transforms wave patterns and gusts into serious stability factors. The project's scale, massive dimensions, massive thrust, massive ambition, signaled a willingness to explore the edges of aerohydrodynamics. It highlighted a logistics niche that traditional transports and ships struggled to fill. The KM showed that exploiting nature's own physics could open a new regime of movement. But the same physics that gave the Ekranoplan its superpower also limited its flexibility. Sea states, weather, and infrastructure all conspired to make routine, year-round operations difficult. Follow-on designs tried to narrow the mission and improve practicality, but the concept never quite overcame the real-world constraints of maintenance, training, and doctrine. Still, the idea refuses to die because the problem it tried to solve, fast, heavy, over-water lift without airfields, has not gone away. Every few years, new prototypes and studies revisit the promise of ground-effect transport, often with modern materials and fly-by-wire control. The KM thus sits in a special category, a proof of possibility that keeps inviting new generations to have another go. If the right mission and technology ever align, its ghost may yet find an operational home. Until then, it remains one of the boldest logistics experiments ever to leave a wake. Number 1. Boeing X-20 Dyna-Soar, USA, 1957-63. Dyna-Soar was a reusable piloted spaceplane at a time when most people were still wrapping their heads around orbital capsules. It envisioned launching atop a rocket, performing missions in space, and then gliding to a runway landing like an aircraft. The vehicle's lifting body winged configuration was meant to give pilots cross-range and precision recovery, traits capsules lacked. Proposed missions ranged from reconnaissance and satellite servicing to rapid response and even kinetic strike, which sounds startlingly contemporary. To make that work, engineers explored hot structure materials, thermal protection, and guidance techniques that would not become mainstream until decades later. The program also sketched out a playbook for training pilots to operate in space and then return to the atmosphere with aircraft-like control. In an era of one-and-done capsules, it embodied the dream of routine, flexible spaceflight. Politics and budgets clipped its wings before it could fully fly, but Dyna-Soar's influence is everywhere. The idea of a winged spacecraft with runway landings matured into later programs, culminating in vehicles that finally matched the concept's ambition. The research on aerothermodynamics, structure, and flight control fed the knowledge base for reusable spaceplanes in the late 20th and early 21st centuries. It's systems thinking, designing for reusability, operability, and multi-mission flexibility, anticipated how modern space operations would eventually be run. The cancellation underscores a recurring theme with ahead-of-their-time projects. Technology can be ready before institutions are. Even so, Dyna-Soar remains a case study in how to design for the world we're heading into, not the one we're leaving behind. It's the clearest example on this list of a prototype that read like the future, and decades later, turned out to be exactly that. Thank you for watching. If you enjoyed it, please like and subscribe. Until next time.